Now let's talk about another way to measure angles. This discussion will lead us to the radian measure of an angle, which in some ways has some more practical usages than the degree measurement of an angle. So I have drawn here a circle, and its center is at the origin, and in order to explain what a radian measure is, I'll need this circle. And I'll start by just drawing an angle, so what exactly it looks like doesn't matter. Let's make it look like this. And so my angle is here. And let's call this angle measurement t. Now I know that earlier I said typically we use lowercase Greek letters, but sometimes lowercase t is used as well. Let's give a label to the radius of this circle. So let's say this has radius r. And now we'll need one more label, and that's going to be a label for the length of this blue arc that I'm drawing. So this arc, let's suppose that it has length s. So the arc begins on the positive x-axis and ends on the circle where the intersection occurs between the angle that I've drawn and the circle. There's a special name for this type of arc. So what we would say is we would say that S is the length of the arc that is subtended by the angle t. And let's say angle t. Angle t. So I haven't defined, or I haven't told you how to find what t is. That is the point of this whole discussion, is I'm going to tell you how do you figure out what t is, and t is going to be the radian measure for this angle. So let's do that now. So t, definition, t, the radian length of this angle that I've drawn, is equal to s divided by r. So it's the length of this arc that is subtended by the angle divided by the radius of this circle. One thing that you can note right away is S is a length and R is a length, and when you do a length divided by a length, you get a dimensionless unit. So T is dimensionless. Now if this all seems really abstract for you, let's do something that might make things a bit clearer. So I have a similar drawing here, and I'm going to figure out what is the radian measure of the angle where the initial side is on the positive x-axis, as always, and we go one full revolution around, and the terminal side also lies on the positive x-axis. Now remember the definition of, let's go ahead and label this t. T is going to be the length of the arc that's subtended divided by the radius. So let's think about the arc that is subtended here. So the arc starts on the initial side where the circle meets the positive x-axis, and in this case this angle goes all the way around, so this arc is going to actually be the whole circle. So all the way around. The arc that is subtended would be the whole circle. In other words, the arc that is subtended in this case is the circumference of the circle. And so in this particular case, t would be equal to, of course, the length of the arc subtended, but the length of the arc subtended is the circumference of the circle divided by the radius, and we know from earlier math classes that the circumference of a circle is 2 pi times r. And of course the radius is the radius, but now I see that the radii cancel, and so this particular radian measure is t equals 2 pi. Another way to say the same thing is that 2 pi radians is the same thing as 360 degrees. And now that we know how many radians it takes to go one full revolution, we can figure out how many radians it takes to go half a revolution, a quarter, and 3/4 a revolution. So let's go back to our quadrantal angles and let's write in the radian equivalent of these angles. So for 360 degrees in the bottom right-hand corner here, we're going to have this angle in radians is 2 pi. Notice that you don't need a degree or any other symbol to indicate that it's radians, you just put the number there. So half of a full revolution, that would be over here, that would be 2 pi divided by 2, which is just going to be pi. And let's go ahead and erase some of these stray marks here. So the angle that is 180 degrees can also be described as pi radians. If we go 1/2 of 180 degrees, or 1/2 of pi radians, then we get the angle over in this very first drawing, which would be pi over 2 radians. So pi over 2 and 90 degrees are the same. And finally, if you travel pi over 2 3 times, then you get to this angle that is in this third drawing over here, which is 270 degrees, or in radian, 3 pi over 2, because it's 3 times pi over 2. So these are the radian measures of the angles that we discussed earlier. And if you recall, we also discussed some of the angles that are in the first quadrant when we first were discussing degree measurements of angles. So let's take a look at this first quadrant. So we know that we'll draw in the angle pi over 2. This angle is pi over 2. And if you were to only go halfway, then half of pi over 2, 1/2 of pi over 2 is pi over 4. So halfway between pi over 2 and halfway between pi over 2 and 0 is pi over 4. This in degree measurement was 45 degrees. A third of the way to pi over 2 would be, well, 1/3 times pi over 2, which would be pi over 6. This was the same as our 30-degree measurement. And finally, if you go pi over 6 twice, then that would get you to the angle of 2 times pi over 6. That's the same thing as pi over 3. And this is the same as 60 degrees. So pi over 3 is the same as 60 degrees, pi over 4, 45 degrees, and pi over 6 is the same as 30 degrees.